Hello everybody, today I'm going to be discussing the difference between simple and compound interest. So first I'm going to start off talking about simple interest. So below I have the simple interest formula, which is S equals P times 1 plus R times T. P in this scenario represents the principal amount, R represents the interest rate, and you would write this as a decimal, and T represents the time, and the time is always described as in years. So I have an example below. So $2,500 is deposited into an account earning 9% simple interest. How much is in the account after 18 months? So in this example, $2,500 would be the principal amount. It is what's being deposited into an account. It is the starting principal amount. And 9% would be the interest rate. Now, to write this as a decimal, it would be written as 0.09. And the time is represented always in years. So time is 18 months. So to find that in years, we're going to divide it 18 divided by 12 months, which equals 1.5 years. So in this scenario, the formula would be S equals 2,500, and then in parentheses it would be 1 plus 0.09 times 1.5. 0.09 represents the interest rate, and the 1.5 represents the time in years. Now we're going to be looking at simple interest. Below to the right, I have just an example of what a simple interest graph might look like. So as you can see, I have mine starting from the origin point. It could start from somewhere else along the x or y-axis depending on that P, the principal amount, and the line is always going to be straight. So an easy way to remember this is to think about the fact that you're adding the same amount each year. That's just the way that I like to think about it. Below I have a little T-chart graph which describes the year. So I have years 1, 2, 3, and 4. And then I have the total amounts increasing. So for year 1, I have $1,000. That would be P, the principal amount. And then every year, it's going up by $25. So for year 2, it's $1,025. For year 3, it's $1,050. For year 4, it's $1,075. So this is just meant to show that every year it's increasing at a steady rate. This is different than compound interest, which doesn't go at a steady rate. So my little arrow example says that it's constant growth. And then I have just written down an example of what a problem would look like. So for example, if a problem said Lily borrows a $5,000 loan from a bank which charges 5% interest each year. So that 5% interest is the same per year. So that would be a way that you could tell that's simple interest and not compound interest, because it's staying at a constant rate of $5,000 per year. Next, I'm going to be moving on to talking about compound interest. So the formula for compound interest is S equals P, and then in parentheses, it's 1 plus I, and that is going to be squared to N. So similar to the last one, I put it in the same color, but P is the principal amount. In this example, I is the interest rate. So I can also be written as R over M. R represents the rate in decimal form, and M represents the number of times that the payment is compounded per year. N in this example means the total amount of compounding periods, and N can also be represented as M, which we talked about above, so the number of times interest is compounded per year. So M times T. T is time, and just like the last one, T is time in years. So my example problem for this one is that you deposit $3,000 into an account earning 12% interest compounded quarterly. How much is in the interest account after 8 years? So for this one, to write out the formula, P, the principal amount, would be $3,000 because you're depositing $3,000 into the account. I would be represented as 0.12. So that shows the 12% interest, and then you're putting it into decimal form and changing it out of the regular form that's written in. And then you're dividing that by 4. The reason you divide it by 4 is that it's compounded quarterly. So quarterly means it's 4 times per year. So 0.12 divided by 4 would equal 0.03. So that's what's going into our I section of our formula. N is represented, as I said above, it's the total count of the compounding periods. In order to calculate that, we're doing 8. 8 represents 8 years, times 4. 4 represents quarterly. That equals 32 periods that the money is being compounded. So for our formula for that one, it would be S equals 3,000, in parentheses, I times plus 0.03. 0.03 again is that I, and then N would be represented as 32. And then just to conclude, lastly, looking at compound interest, as you can see, the graph looks different than the last one. This graph is not a straight line. This is an exponential graph, so there's a curve to it. That is because you can think about it as your interest grows more and more over time. So as you can see in our T-chart, instead of the last one and simple interest, like it's going up by the same amount, you're adding $100 per month or per year in this example, plus 10% of the previous amount. So then just an example for that would be Emma takes out a $5,000 loan. The bank charges 5% interest compounded yearly. She will pay it back in 3 years. So that is just an example of it is not constant growth. And that is the difference between simple and compound interest.